As Brian mentioned, my name is Harry Pearson. I am the Chief Architect of the NEO Global Development Seattle office. NEO Global Development is the research and development arm of the NEO Foundation, which is an organization primarily focused in the blockchain and smart economy space. And we're here today, well, we, the royal we, John here in spirit, to talk about how interesting this environment is, this platform is for .NET developers, right? I've spent my entire career in the developer experience space, starting in Microsoft Consulting, working with customers like yourselves, working through the product groups, as Brian mentioned, Iron Python, Windows Runtime, Xlang. My entire career has been focused on making developers' lives easier. And this platform, NEO, is really fascinating. And it's the reason why I left Microsoft about 6 months ago to come over and run this organization, the technical side of this organization. We all are spending a lot of time focusing on the cloud, right? Obviously, there's a lot of talks here at this conference on Azure. I'm sure that everybody here is focused on technologies like Azure or AWS or Google App Platform or whatever other types of environments that you care about, specific platform vendors that you care about. But one of the things that we focus on with NEO Global Development is what comes next. And if you've been around this industry as long as Brian and I have, or you've studied this industry, you know that there's a pendulum swing. We go back and forth between centralization and decentralization. We bring things to the center, we push things to the edge. And I'm personally very much a believer in using the right tool for the right job. Some types of problems are best suited to be solved with a centralized technology, right? If you look at what it costs to build out these football stadium-sized data centers that Microsoft and Amazon and Google and et cetera are all building out, that's really hard to decentralize. On the other hand, you're talking about a set of capabilities in devices like these, right? When you stop and think about the fact that this phone is more powerful than the computers that put man on the moon. Literally, that's not exaggeration. You go and you look at the museums. I got an opportunity to visit I'm blanking on the name, the aircraft carrier in San Francisco that picked up the astronauts when they came back from the moon. And they actually have an iPhone 5 or something, or this is how much more powerful this phone is than the computers that put man on the moon. And yet, what do we use it for? Drawing pixels. Certain problems, best suited centralized, but we also want to make sure that we can take advantage of the capabilities on the local device to provide a better experience for users and a better experience for developers building out solutions, the next generation of solutions. Now, there's a lot of decentralized technologies out there. The W3C is in the process of writing out specifications for decentralized identity. There are decentralized file systems. There are decentralized databases. But I'm here in particular to talk about blockchain. And there's a reason why we're so focused on blockchain at NEO, amongst all these other distributed decentralized technologies. Blockchain is the only technology platform that has a baked-in economic model. The network, the internet, computing in general is really, really, really good at making copies of things, right? If I'm going to send you an email, what I'm really doing is I'm writing a document and I'm sending you a copy of it. And that works great for sharing documents or sharing photos of my new dog with my wife or what have you. But when you're talking about assets, when you're talking about value, when you're talking about money, I don't want to send a copy of $10. I don't want to send a copy of the deed to a piece of land. I want to actually transfer that. And these types of problems have essentially two solutions. One is to have trust in a centralized authority. This is primarily the way that these types of things are done today. We clear financial transactions with large organizations like banks. Blockchain is a way to do this in a decentralized, detrusted format, right? An organization that doesn't have a central point of control or a central point of authority, that doesn't have a central point of attack, that doesn't have a central point of compromise. Now, this is enabled by a lot of these technologies that we've seen getting built out over the course of the last few years. We have distributed ledgers, which lead to the ability to do what are called cryptocurrencies, which is the foundational technologies we use for building out the smart economy. So distributed ledger, right? You guys are familiar with databases, right? If you know very much about a database, the database has got a bunch of tables, but it also has a transaction log. A mentor of mine, a gentleman named Pat Helen, one time joked that the transaction log is the real data. The tables are just a cache of what's in the log, right? A distributed ledger is like a transaction log. In fact, it is a transaction log. It is a write-only data structure. You write a series of blocks. These blocks contain transactions, and they are all hashed so that they cannot be modified. Each block has a pointer to the previous block, so you can't go in and make any changes to it. Now, these types of chains of a transaction log have been around in the industry for a long time, but what makes this one specifically different is the fact that it's distributed. We have a series of servers that are called consensus nodes that come to agreement as to what is and what is not in a given block. This data is replicated geographically and does not have a central point of administration. If you want to go and bring up your own server and connect it to one of these blockchain networks, you don't have to get permission. You don't have to apply for authority. You can simply join your machine to the network and start to participate. Now, this is just data. This is just a way of thinking about how we write data in a way that can be globally replicated and without a level of centralized control. This allows us to build cryptocurrencies. Cryptocurrencies are digital assets. They are cryptographically signed, so when we talk about cryptographics, remember, we're not talking about encryption. We're talking about digital signatures, right? This data is publicly available, and in a lot of scenarios in lots of parts of the world, the fact that this information is not only untamperable, but is also globally readable is a very critical feature of the technology. You can't hide these things on the blockchain. These assets can be used in terms for fiscal transactions. Again, the whole point of this technology is to be able to transfer without copy, transfer ownership in a decentralized fashion without a central point of authority. These technologies allow us to deliver this smart economy, a decentralized open network with this intrinsic economic model and no single point of failure. And this, we believe at Neo Global Development, the reason why John formed this organization, the Seattle office, there's a Shanghai office for Neo Global Development, why he brought me on board. John and I wish he was here. Right? He does this part of the talk a lot better than I do. And John and I go way back. He was my boss, and back when I first met Brian, when we were talking about 15 years ago, I was working for a team called Architecture Strategy, and John and I would discuss architectural impacts of what we then called peer-to-peer technology. And today that's more decentralized, same basic idea. What would be the impact on enterprise software if you built ERP or CRM systems with peer-to-peer technology instead of traditional centralized? So this is an area that I've been primarily focused on for a very long time. And we believe it's a fundamental game changer to how technology can be delivered and the types of solutions that we can bring around the world. Now, the thing that's really fascinating about this is that blockchain, I don't know about you guys, but I come to this from a platform perspective. I don't have a deep background in blockchain or crypto. So it's easy to come up with this idea that, oh yeah, that's just some Bitcoin thing, and I don't really understand it, and it's just a bunch of, who knows what, or this intrinsic economic model makes blockchain really fascinating for a wide variety of scenarios. And what's also interesting is the groups of people that are investing time and money and research efforts in this. I recently spoke at the IEEE blockchain conference in Bethesda, Maryland, in Gaithersburg, Maryland, a few months ago. It was held at the National Institute of Standards and Technology. That organization has actually done research into what it would take for a state, like a nation state, to issue cryptocurrency as instead of a fiat currency. What would be the impact? I got a chance to meet the woman who's responsible for the ISO blockchain reference architecture standards. Groups like IEEE, NIST, and ISO do not spend time and effort on technologies that don't have an opportunity to change the world. This is why I got involved with blockchain. This is why we're here today to talk to you about this really fascinating technology. So, okay, blockchain, great. Great idea. We're sold. We want to hear more about it. But why NEO in particular? There are a lot of blockchains. There are a lot of digital tokens out there. So what is it that makes NEO such an interesting thing to work on in this space? There are two primary things of interest that I want to talk to you about. The first is single block finality. Now, I know that this sounds like some kind of weird emo band name, but it's actually a really critical piece. We talked earlier a little bit about consensus. There's no central point of authority. So you have a group of servers that are known as consensus nodes that come to an agreement in an untrusted, decentralized fashion as to what is and what is not in the blockchain. Transactions that are agreed upon that are in, are obviously really important. If you're standing there trying to do a transfer of digital assets, like you're at a point of sale at a store, you need to know very quickly whether or not your transaction has made it into the blockchain or not. There are a variety of different ways that these consensus nodes reach consensus. You're probably at least somewhat familiar with Bitcoin, with the idea of mining rigs and the sheer massive amount of power that these types of rigs draw. The custom hardware, the energy, electricity draw, what have you. There is significant financial opportunity in mining Bitcoins. That's the reason why these organizations invest in this kind of custom hardware. This is a model that's known in the industry as proof of work. We're basically going to give you a really hard math problem, and the first one to solve it gets a reward. The problem with this model is that it leads to what are called forks. I have this miner who's working on a fork of blocks, and I have that miner that's working on a set of blocks. They don't always have the exact same blocks in each chain. Those blocks don't always have the same transactions in each chain. Eventually, that has to resolve, and it can take time. It can take literally up to an hour or two for you to reach block finality in a proof of work system. This is the reason why if you've ever experimented with blockchain, if you've ever invested in Bitcoin, if you want to transfer your resources, you transfer your assets, it takes a very long time for those assets to be finalized for you to be able to actually access them when you move them between systems. This is inherent to the model that Bitcoin uses. So not only is it a gigantic power draw, which is horribly inefficient, it also takes an extremely long time in order to reach consensus. This is clearly not a model that's going to work for individual consumers. This is clearly not a model that's going to work for my wife or my mom. NEO uses a system called proof of stake. People who own NEO can vote on what the consensus nodes are. The consensus nodes reach this finality within every individual block. We ship a new block of NEO every 15 seconds. 15 seconds, when you're a developer sitting waiting for that block to finish, takes a long time, you get tired of it. We'll talk a little bit about that when we get to the code demo. But for a point of sale type of scenario, 15 seconds is no problem. And we're actually reducing that in the future. We reach block finality immediately, and it's one of the things that we believe makes NEO a platform that is fascinating to build on, that you can build real economic solutions on top of. The other thing is that NEO, long before I joined NEO's been around since 2014. It was originally known as Ant Shares, and it was rebranded in 2017. So long before I knew about it, long before I joined, long before we opened the Seattle office, this organization has embraced developers and a developer experience that is unparalleled in the crypto industry. Most of the other platforms in the industry require you to use their specialized tools and their specialized languages. Another blockchain that you might have heard of is called Ethereum. They have their own custom language for building smart contracts called Solidity. We in Neo believe that we want to meet developers where they are. So we're going to see writing smart contracts here today in C#. I'm going to show you a contract that I wrote in C# that I originally ported from Python. You can also have contracts written in Go, in TypeScript. There is some work going on to produce a Java compiler and other languages as well. We want to fit into the world that you live in today, the tools that you use today. We don't want to replace them, we want to add on to them. As you'll see here in a little bit, all of our stuff that we're shipping as part of the Neo Blockchain Toolkit, which is the product that I am primarily responsible for, are all around .NET. I imagine that a lot of people in this room are .NET developers. It uses Visual Studio Code. We want to extend that to support Visual Studio for Mac, but we're starting with Visual Studio Code. Visual Studio Code, I imagine a lot of people in this room use Visual Studio Code. It's the fastest growing IDE according to Stack Overflow, and has actually overtaken Visual Studio in popularity across the industry. So plugging into these familiar tools, using these familiar languages, are a way of making sure that you don't have to learn the least amount of new things in order to take advantage of this environment. We were recently accepted into the .NET Foundation. Neo is primarily implemented in C#. Now again, we want to be able to plug into these other languages, but our core implementation is written on top of C#. We are the first blockchain to be accepted into the .NET Foundation. It is, as you can imagine, open source, available on GitHub. All the stuff that you're going to see today is available today for both, to peruse the source code, for opening issues, making PRs, what have you. And as all things in software, we are not standing still. The current version of Neo that's out there, version 1 was, as I mentioned earlier, was branded as AntShares. Version 2 was part of the rebrand where they moved to Neo as a name. We are currently in the process of building what we call Neo 3, which adds significantly new functionality to the underlying platform. We are adding what we call NeoFS, which is a decentralized file store, not only good for developers, but also for consumers. You actually can provide file share storage on your personal machine in a decentralized fashion and be rewarded for that. We're working on a decentralized identity infrastructure called Seraph ID. This, as I mentioned earlier, is working with the various W3C decentralized token, identity token standards. We're also working about a technology known as oracles. Now, of course, in the technology industry, Oracle is a big database company. That's not what we're talking about. One of the things that you discover when you work in this space is that in order for you to reach consensus, it's very important that custom code, smart contracts, are deterministic. We're going to run this smart contract on every consensus node, and every single one of them has to come to the same answer. So there are certain operations that are just not allowed. Like, what time is it right now? Chances are, if I ask that question on 7 different servers, I'm going to get 7 different answers. So it's important to be able to say that it's important to not allow that kind of an operation. You can say, what was the time of the last block? That's going to be deterministic. Everybody in the blockchain is going to agree on that. But the current time is not something you're allowed to access. The internet is heavily non-deterministic. So being able to go off and talk to the internet and to get data from outside sources is something that's not available in most blockchains today. Oracles is a new technology that we're working on for Neo that's going to allow the Neo blockchain to connect to the outside world in a deterministic fashion. These technologies are going to make it possible to build even more powerful solutions on top of this technology. So, I've been talking about it for a long time. Let's take a look at it. So, I'm going to point out real quick, I'm going to give you the link to this a little bit later, but this is a Visual Studio Code extension plus a set of .NET Global tools that you can install on the command line. Over time, we're going to make this a better integrated experience. I've been at Neo for all of about 6 months, so you're seeing the first 6 months worth of work. We continue to improve this all the time. Now that we're shipping, we shipped our first release in September, we shipped our second release in November, so we're going to be on a sort of 2-month cycle for shipping new releases and new functionality. So you're seeing where we are currently. I'm going to start by creating a new directory called Hello World. And there's nothing in here, and I'm going to bring up, oh, hey, what if I, sorry about that. I thought I was on, there we go. So I'm in this empty directory called Hello World. And what do we do in .NET Core when we want to create a new project? We say .NET New. And so one of the tools that you can install is a .NET template pack, plugs directly into this infrastructure, so I can say .NET New Neo contract. Now temporarily, I'm using a fork of the Neo compiler that generates debug information that drives the debug experience that we're going to see here in a minute. Over time, we want to merge that back into the mainline code branch, but we haven't finalized the format. As I mentioned, we have all these other compilers, the JavaScript, TypeScript compiler, the Go compiler, the Python compiler. So we're currently working with the teams that own those different compilers to finalize the debug format. And once we do that, we're going to merge this into the final product. So temporarily, we have to say -DE. This is just a flag to the template that says we're not using the standard version of the Neon compiler. We're using the debug enhancements version. And it's created the template. And you'll notice here in Visual Studio Code that I have just what is normal C#. I have a CS projects file, and I have this directory build targets, which is, yes, I do not need that, which is going to also run the Neon compiler. So Neon is the Neo for .NET compiler. It takes code written in C#. You take your C# code, you compile it with the normal C# tools, it generates a DLL. We run that DLL through a secondary compiler, which outputs Neo VM code. So now I'm going to add a build task. This is just standard stuff that you do in Visual Studio Code. I am going to make one change due to a bug we currently have fixed in a topic branch, but has not been made it in the main line. You have to use publish instead of build. And now I'm going to build this code. And I'm going to bring up the running tasks window. Oh, did we already build it? That was fast. Hey, what if I actually save that? That might work better. Okay, so I'm not sure why it's not working from the build screen, but you can see here that I've run this first stuff here is just the normal .NET build process, and then we're running this through the Neo compiler, and it's generating a bunch of additional files. Here in the publish directory, this AVM file is the equivalent of a DLL in the Neo. It's the bytecode that the Neo compiler, the Neo runtime uses. We have the debug information. This is similar conceptually to the PDB. And we also have a file that defines the application binary interface of all the methods that are in it. Now this is a very simple, we'll see much more interesting smart contracts here in a little bit. This is a very simple one that will write hello world to the storage that's associated with this contract. Every contract has an associated storage space on the blockchain. And we'll see later, using that information to write financial information. Here, we're just writing hello world. It's not very interesting. But let's start here, nice and simple. Let's see it in the debugger. So we've built it, now we want to actually debug it. So I'm going to come up here and I'm going to say add configuration. And this is all probably pretty familiar if you've used Visual Studio Code before. You'll notice here that we now have Neo contract. This is a special debugger specifically for Neo smart contracts. And I do not need to install the new version of PowerShell. Thanks for asking. So This now creates what's called a launch JSON file. This is what drives the debugger experience in Visual Studio Code. This is just standard Visual Studio Code stuff. And you'll see here that I have just a path. It's automatically figured out where my AVM file is. And I can now run this, and I'm stepping through it. And I realize this is not that exciting, right? This is great. So it's a C# debugger. Woo-hoo. We've had this for a long time. Except the thing that's interesting about this is that this is not running on the CLR. This is running on the Neo virtual machine. It's written in C#, but we're not actually running on the CLR, and that's a really important thing here. We're trying to deliver a debugging experience that is familiar to you as a .NET developer. But again, this is running on a completely different virtual machine. And you can see a couple of things about this. For example, you'll notice that this is a very simple blockchain, very simple storage, a very simple contract, so we don't actually have any local variables. And we haven't actually written any storage yet, so but as I walk through here, we'll see here that this is going to write some information to storage, and we'll see that it shows up here in the storage node of the variables. So this tells me that I have this key and this value. Now these are byte streams, or just hex code, these are byte arrays encoded in hex. This isn't very useful to be able to read. So I can actually add this to the watch window and tell it, I'll bring this a little wider here. I can tell it, hey, you know what? I want you to treat this as a string. And I have to actually put this in the correct place. So it now can automatically decode this. By design, we automatically encode all strings as UTF-8 for storage. Obviously, you could do that conversion yourself, but it's a lot more convenient to write this information directly as in a string format. Now, in this example, we're running on top of the Neo virtual machine independent of any actual blockchain. So this is all just getting stored in memory. We're not actually storing this in a blockchain. Every time I run this, I'm going to have the exact same experience because I've got this configuration set ahead of time. So this is a pretty simple example. Let's maybe look at something a little bit more interesting. So this is a standard example that Neo ships. This is available up on our GitHub as well. And this is kind of like a little domain registry. I'm sure you're all familiar with domain registries. Now, this one doesn't not use the financial model at all. So you can imagine in a real domain registry, you're going to buy and sell. We don't have that here. But what we are doing here is this simple basic idea of being able to register and query for domain names. Now, you'll notice here a couple of things. First off, we have a main function. I'm going to close this for just a second so we can better see. And if you're at all familiar with building a command line app in .NET, you know that it's very common to pass in a set of standard arguments that need to get parsed. We do the same thing here. We have a standard entry point for main, and then we fork off to some other part of the code based on the parameters that are passed in. In this specific example, there are 4 different things that you can do. You can query, you can register, you can transfer, and you can delete. We're only going to look at query and register here today. Query basically says, I want to use this domain as a key, and I want to get that value out of storage. Register says, I want to check to make sure that there is no existing value for something, and if there is, I want to put it. Now, you'll also notice here this idea of runtime check witness. So one of the things that we talked about earlier is this idea of digital identity. It's important that only individual people are allowed to do individual operations. So we actually have built into the runtime framework the ability to check ownership, to be able to validate the people, the addresses that are being passed in as parameters versus the address of the person invoking the transaction. And that's what this check witness operation does. It says, I'm making sure that the owner address that's passed in as a byte array matches the owner that actually invoked this transaction. Now in the debugger, we don't want to have to write that by hand, right? We don't want to have to maintain and manage all the list of witnesses and what have you. So if you look in launch.json, you'll notice that there's this little configuration here that allows me to specify, yeah, I just want to bypass that check. I can also make this false if I want to, and there's also a way I can configure it where I can actually specify the list of witnesses that I want to be valid. But for here, we're basically saying we want to bypass that check. So this, again, just allows me to maintain identity. We'll see this more in the next demo, where we actually care a lot about the ownership. We need to make sure that only certain people are allowed to invoke certain operations in the smart contract. So now I'm going to come back over here to the debugger, and I'm going to show you, this has actually 4 different configurations. Let me close this down again so we can actually see it. I want to be able to query when the storage is empty, or I want to be able to query when it's full. So this is another aspect of this, is the ability to actually configure that storage. We saw in the last demo that we were able to write to the contract storage as part of the debugging experience. Here, we want to do the same kind of thing, except we want to actually pre-configure it. We want there to actually be storage ready to go. So I can actually configure that. There's a large number of settings. It's all documented up on the GitHub repo, of course. But there's a large number of settings that you can use to control the behavior of the virtual machine. And this is important because as a developer, you need to be able to put your environment into a known state in order to be able to debug certain scenarios. So we give you a lot of controls. You don't have to use all of them, but we give you a lot of knobs that you can turn. So if we look at query full, and we step in here, we'll notice right off the bat that earlier storage was empty at the start, but now we actually have values in here. And if we expand this out so you can read it, you can see here that I've added in the watch window, we don't need this one, I've already cast it to a string so that we can actually see the value, that the Neo Foundation owns the domain neo.org. So now I can actually step into the code, and we can see something very similar. And again, you'll notice that I have breakpoints here. Again, this isn't rocket science, this is normal C# debugging, but running on top of a completely different virtual machine in a deterministic smart contract blockchain instead of inside of a normal C# CLR type of environment. I'm going to expand this out here, and we'll actually see here that it's returned a value in the blockchain. So we actually can get the output of invoking the smart contract right here in the debug window. We can also attempt to register a new account. You'll notice here that, by the way, we all have args, so this is just like program args. So here for register succeed, we have an empty storage, and for register fail, I'm going to try and register neo.org, but neo.org is already going to be owned by the Neo Foundation, so it's not going to succeed. Whoops, sorry about that. It scrolls off the screen. So now I'm going to, again, just going to run to the next breakpoint. I see that I have a variety of locals here. Who's the owner? What are these values? Not all, in the CLR, not all of these locals are going to have friendly names. A lot of these are used for local variables for like return values and stuff like that. So as I step through, as you saw, I went past the check witness. I'm trying to get the current storage. Current storage is an empty byte array, so that's the way we represent null. So this allows me to say, okay, great, this is not registered. So I'm going to add this to, whoops, let's just get this scrolled off. This now adds it to storage, and I can continue, and it returns true. And we'll get the, let's actually return true. If I say I want to register fail, now I'm going to try and register again as myself. So I'm trying to register neo.org as me. That's represented as a byte array here. Now I go to get, and we'll see that there's actually a value that when we return from storage. This is not null, so as I step in, it's going to return false. Right? Again, the whole point of this is this should feel very familiar to you as a .NET developer because it's just C#. It's just a normal C# debugger. But again, running in this very different environment. So now let's actually see a sample that's a little more interesting. I ported this sample. This was if I can actually. This is a sample that is known as escrow. It was originally written by a member of the Neo community named How9000. I mean, that's not his real name, but that's that's his handle. His real name is Joe Stewart, excuse me. And so I want to give him complete credit. I've ported this to C# because, as I mentioned earlier, the debug information that's currently needed to drive the experience that we just saw is only available in C# today. We are currently working with the community to bring that debug information. There's nothing in the compiler, there's nothing in the debugger that is C# specific. It's built in C# because Neo Virtual Machine is built in C#. But the debugger has been explicitly designed to support the different languages that Neo supports. So any language that Neo supports that can emit the debug information can also run in this environment. So we're currently working with the owners of those other tools to be able to bring the same experience to JavaScript, to Go, to Java, and to Python. But since that's not available today, I've ported this over to run in C#. So this is a much more complicated, as you can see. It's much longer. I mean, it's 300 lines of code. It's not that long, but it's a lot more complicated than one line of code, which is the hello world, or a couple of dozen lines of code, which is the domain sample. This is a scenario where I'm going to put something up for sale, and somebody is going to buy it. I'm going to confirm that I shipped it. They're going to confirm that they've received it, and it's going to then release the funds. Now, the way that this specific business scenario works is when I go to put this object up for sale, I have to provide twice as much assets, Neo assets, as I'm selling the product for. Then the person who's buying it has to offer up twice as much Neo. So I'm going to sell this. I'm selling a widget because I am not very creative when it comes to thinking of new things to sell. And if we go to launch.json here, we'll see here that I have a large number. There's many more. We're not going to walk through all of these. Don't worry. We only have about 15 minutes here left. But there's a large number of these different operations that I can run in the debugger. It's actually one of the things that I like a lot about Visual Studio Code relative to the full-blown version of Visual Studio. It's a lot easier to configure these different debug scenarios. But if we look at create sale, I'm going to create a sale that is, I'm going to sell a cool widget for 100 Neo. In order to be able to sell this widget for 100 Neo, I have to submit 200 Neo to the contract. So I'm going to transfer 200 Neo from myself to this contract as part of this operation. The buyer will transfer 200 Neo, and then when the entire process is completed, it will return 300 Neo to the buyer and 100 Neo to the seller. The reason why you have to provide twice as much is as an incentive to complete the process. This is a business decision that was made in the original contract. I just ported it over to C#. You can imagine a variety of different scenarios here. But the critical thing to realize is that this economic model is baked right into the underlying platform. I don't have to go off and build some other system to manage this. These assets are right there and part of the platform. And in fact, if you'll notice here that we've seen some of these other properties before. We saw program, we saw args, we saw storage. Well, now we have this new configuration called UTXO. UTXO is the underlying transaction model that is used to manage Neo and on the blockchain. So this basically says, hey, there's this existing transaction that I own, a bunch of Neo. That's what I want to use as the input. And then I want to transfer 200 Neo to this owner, which, as it turns out, is the name of the contract. So there's a tool you can use that will provide this information. In fact, actually, let's talk about that for a little bit. One of the other things that you need, in addition to this debugger, in order to really get a good experience of building for Neo, is you need an actual copy of the blockchain. Neo traditionally has shipped two different pieces of code to run a Neo blockchain node. A command line tool called Neo CLI and a Windows Forms app called Neo GUI. And these are great tools for the specific scenarios in which they are designed, which is to say they're not designed for developers. Developers have additional requirements that you would actually never really want to do on a real blockchain. I want to be able to set up a brand new blockchain instantly. I don't want to have to mess around. I don't want to have to take a lot of time. As you can imagine, in production blockchains, you don't do that very often, so it's okay if it takes a long time to set it up. I need to be able to do things like roll back to a previous, I want to throw away all my blocks. I want to roll back to a previous state. These are things you care about a lot in development that you would never do on a production blockchain. We talked earlier about the fact that distributed, decentralized ledger is a write-only store. If you throw away data, it's no longer write-only. So on a production blockchain, you would never, ever throw data away. That's against the rules. But while you're developing, you want to make sure that your development environment is in a known state. We do some of that in the debugger, and we're working on a unit test framework that uses the same approach. But sometimes you need you need the full blockchain. You need to be able to do things like, I actually need assets that I can transfer around. You'll notice, by the way, that there's this other configuration here called checkpoint. And this plugs into a tool that we ship called NeoExpress. NeoExpress is a .NET global tool, so you can get it just by install. I've already got it installed, of course, but you can get it, and this is all in the instructions. I'll send a link. I'll put up a link at the end. So if I say .NET tool install neoexpress.g, it'll automatically install the tool. As I said, I've already got it installed, so I'm not going to do that. What this allows me to do, and I'm actually going to go over to the Hello World one just for a second to demonstrate this, because I've already got one in the escrow sample we'll see in a minute. It allows me to create a new instance of the Neo blockchain that quickly, instantly. You'll notice here there's a warning. We're storing everything in an unencrypted fashion. This is specifically for development. I don't know about you guys, but whenever I have to maintain passwords for my development environment, I invariably use insecure passwords like password, right? And so instead of doing all that, I don't want to have to think about that. I'm just going to store this information unencrypted. Now, these are real Neo accounts. If you wanted to, you could use these addresses, these private keys, these public keys up on the public mainnet. But we tell you right here, don't do that because this is unencrypted. If you're using real Neo on a real mainnet, you need to maintain good security. There are a lot of wallet and applications that help you do that in a secure fashion on mainnet. This is not for that. This is purely for development. And that generates this file called default.neoexpress.json. You can, of course, change it to something else. And this has all the information that you need to know in order to be able to run a Neo blockchain. Now, this is a single node blockchain. We talked earlier about consensus. Typically, consensus requires 4 or 7 nodes. The consensus algorithm Neo uses is this very innovative approach called delegated Byzantine fault tolerance. It's not my area of expertise, but the key thing about it is that it allows for explicitly faulty or bad actors. You can have up to, as long as you have 2/3 plus 1 good actors in your system, you can actually tolerate bad actors who are actively attempting to subvert the system. It's a very innovative approach to reaching consensus, and is one of the driving factors that allows us to get single block finality. But for development purposes, I don't care. I just want to run a single node because that's going to be the easiest. And it turns out that some of the capabilities like checkpointing and rollback require a single node because you can't maintain that stuff across multiple nodes. So now that I actually have created my blockchain in a second, I want to run it. So I can say Neo Express run. Very difficult. And this will now spin up a new blockchain instance, and it's actually up and running, and I can actually start talking to it. Now, one thing about this, as I mentioned earlier, is that we create a block every 15 seconds. So if I stand up here and song and dance for 15 seconds, we'll get another block in 50, there it is. Comes every 15 seconds. So here we are 29, here we are 44. 15 seconds doesn't sound like a long amount of time, but you had to hear me pretend to sing and dance for 15 seconds, and that sounded, I imagine, like a long time. So when you're doing development, a lot of times you want to actually run this blockchain faster. So you can actually say, I want to run seconds per block, or if you don't really want to write it all the way out like that, you can just say -s. I'm going to run a block every second. The first block, when it's configuring, takes a little longer, but now it's going to run a set block every second. So the goal here is to be able to very quickly do transactions, get operations done, and be able to see the results immediately and quickly. So I'm going to pop back over to Visual Studio Code while that's running in the background, open up a new terminal, close this out, bring this open a little bit, and now I can do operations running against that blockchain. Actually, the first thing I'm going to do is I'm going to show you something called the Visual Dev Tracker. So I mentioned earlier that one of the cool things about a blockchain is that all the data is public. And it is very common in pretty much any blockchain, including NEO, to provide what is called a tracker. So if you go up to neoscan.io or neotracker.io, these are sites that maintain a UI for you to explore the blockchain, the mainnet blockchain. We're providing a very similar experience directly here inside of Visual Studio Code. So I can connect here and I can actually see a list of all the blocks. And as you can see here, because I'm running every 15 seconds, they're updating in real time. Now, this is pretty uninteresting because these blocks are all, there's nothing actually happening, right? We generate a block every 15 seconds. Well, now I'm generating a block every second if there's any activity or not, right? That's the rule. So one of the things that we've done is we've actually added this hide empty blocks feature. So now I only see the blocks that have actually anything interesting in them. And because I literally just created this blockchain, there's only one block that has more than a single transaction in it. And this is what's called the Genesis block. And I can actually click on it. This is the block that creates the original NEO. NEO actually uses what's called a dual token model. There's a governance token known as NEO, and there's a utility token that's known as gas. The ability to vote on things like consensus nodes is derived from NEO. The ability to do operations on the blockchain is derived from gas. So when you want to deploy a contract or invoke a contract, it costs gas. And that's what this here is doing. This is registering, well, we're not going to look at the details, but this is basically registering some NEO and registering some gas as those are the currencies, and it's issuing them to what's called the Genesis account. And let's actually see that Genesis account. Let's go back to showing my terminal. I can also, by the way, if I want to see something more interesting, is I can actually click on and connect to the mainnet. So this is the actual mainnet running out on the internet today. You can see here there's going to be more interesting operations here. This one's only going to update every 15 seconds. But I can see that this block had a couple of transactions, a gas claim, and every transaction has a minor transaction. That's the default, there's a block here. So, we can close these down. And we will close this down, and we will go back to the terminal. And I can actually see, hey, what if I actually type this here? And if I'm actually going to show, I'm going to show the tokens that the Genesis account owns. So right now, this isn't the most user-friendly experience. We're dumping JSON to the console. As you can imagine, part of the goal here is that we want to make this experience entirely working inside of Visual Studio Code. So if we go back here for a second to the NEO RPC server window, you'll notice that there's a start and a stop button. So I can actually start and stop the node directly inside of this environment. We want to add the ability to control it, to create it. We want to add all of these other operations that require the command line today. We want to be able to do all of it inside of Visual Studio Code. But we've only been in development on this visual tracker for about 2 months now. So you're seeing the very beginnings of this work. Over time, it's going to get more powerful. This shows me how much NEO and how much gas is associated with a given account. And we showed this earlier. I see how my indentation has got a bug in it. I'll have to fix that at some point. That this representation here is matching this representation here. The value is unnecessary. So these tools are designed so I can actually go to this tool and say, gee, I'm going to copy this information here and paste it into the debugger. The other thing that's critical here is the ability for me to take what's called a checkpoint. So I can come over here and I can bring back my terminal window, and I can say NEO Express checkpoint create. And again, I know this is a command line experience. We're going to have this entire experience in the next few months running inside of Visual Studio Code, so you won't have to use command line if you don't want to. Create checkpoint CP1 online. Now, what's important about this is I've now taken the state of the blockchain and put it in this. It's essentially a zip file, like many things. We just zip a bunch of these files together and store it with a custom extension. Now, this is important because this is a known state of the blockchain. So I can always go back to it. So you'll notice here that we're at block 330, 331. I'm going to shut this down, and I'm going to say Neo Express checkpoint, restore CP1, and it says, hey, you're overwriting data. You have to use the force command. So I'm going to add force, and it's now overwritten it. So if I now go back and I say I want to run this again, we'll see that we've bumped back to 308. And again, the first block always takes a few extra seconds. Again, this is something you would never do on a production blockchain, but it's really valuable in development. I realize I'm sounding like I'm sort of patting myself on the back because I'm the one who implemented this, but it's actually amazing how useful this feature is. Because not only can I restore, I can also run the checkpoint directly. So you'll notice that we were on block 326, and if I start the blockchain again, it's going to pick up where it left off, 326, 327, 328, blah, blah, blah. But I can also say, I want to run the checkpoint. And we now see that we're back at 308, and it's going to start over again. Now, the thing that's nice here is that what's happening is that it's opened that checkpoint in a read-only fashion, and it's writing all of the new operations to memory. So if I shut this down, we were at 321, and I started again, we're back to 308. So for development purposes, for debugging purposes, for test purposes, this is really useful. And in fact, if we go back to the escrow scenario, you'll see that we have the ability to say, hey, I have this file called checkpoint. I have a setting for checkpoint. I've got this zoomed in a little bit so it's easier for you guys to read. And it's a path to a checkpoint in the folder. This is checked into Git. So if you go up to the repo tomorrow or later today and you want to use these tools, you can check this code out. This works directly. So this allows me to actually have blockchain data associated with this specific operation that I'm about to run. So if I go and say I want to create a sale, so what I've done is I've created this blockchain, I've transferred I've created a couple of accounts for the buyer and the seller, I've transferred Neo to each of those accounts so they have some Neo to play with, and I configured that all the way that I wanted it. And then I checkpointed it. So I can always go back to it, or I can run this in the debugger. So now I say I want to create a sale. And it's opening that up, and again, we're going to walk through the debugger. I'm going to skip through the main because it's not very interesting. And it's going to go through and it's going to do some validation. First off, it's going to make sure that I've not set a negative price. And then it's going to go off and it's going to say, great, I'm going to go get the transaction that's associated with this invocation, and I'm going to get the sender, and I've got this little helper function because I use getSender on a variety of places. And this is going to go off and find out the name, the account that's associated with the invocation of this transaction. And it's just checking a bunch of stuff and returning that as a byte array. And it's going to make sure that it's not null, so that it's actually a valid account. In this specific example, anybody can create a sale. But in later examples in this same, which we're not going to get a chance to talk about, you actually validate the owner. Only the buyer can call receive shipment. Only the seller can call confirm shipment. Now I'm going to walk through that transaction, and I'm going to get a list of the outputs, and I'm going to add them all up. Right? I'm basically counting up how much Neo is being sent to the account. Now, this is one little thing here. We have the value is, we track this in a, this has like 8 extra, we track this as an integer, but we also, and I didn't really talk about this earlier, it's a special data type called fixed8, which adds the ability to track a floating point number as an integer by adding essentially 8 decimal points, 8 values after the decimal points. You have to divide it by 10 to the 8, which is what this code is doing. So it's checking to make sure that the value equals the price times 2, and plus it has this divisor in it. And then it's going to create the sale information. It's going to put it into storage, which we can see here if we close this down again. This is the information about the storage. And then it will raise this event. And that event, you'll see, it shows directly up here in the experience. So new sale is actually just a .NET event. Excuse me. So I'm just defining my own delegate, and I'm creating my own event that I'm just raising. Again, the whole point of this is it just feels like normal C# code. And if I then continue to run it, we'll see that we've returned 1. That's the state that says we've created a new block, we've created a new sale. I'm going to jump here and look at get balance. At the end of the process, we're going to transfer 300 NEO because we're selling this thing for 100. Each the buyer and the seller has to put in 200. And so we're now going to, at the end, we're going to see the balances. And so there's another operation called get balance. This is running against a different instance of a different checkpoint. So this is running against the CP2 checkpoint, seller and buyer configured. And if we scroll to the bottom here, we'll see that and again, all of these different experiences you can work through yourself. Receive confirmation. So this is at the end of the process. We want to just sort of check to make sure the balance of each of these is what we expect it to be. And if we run this, it's going to go off and it's going to look in the storage. It's going to get the information about the amount of funds that have been transferred into this specific account and return that as a value. Unfortunately, this comes back as a deserialized byte array that represents a C# big int. So I have a little script file. Hex to big int, which converts it and confirms that we've gotten 300 NEO back. I put in 200, I sold the product, I shipped it, receipt was confirmed, and I received back my original 200 deposit plus the 100 that came from the buyer. As you can imagine, if you do the other side with this with the buyer, you'll get back 100. So with that, I'm pretty much out of time. NEO, as I said earlier, as a quick summary, I bring this up actually in a nicer view at the end. I used to remember the command lines for the shortcuts for jump to the end, but I don't remember it anymore because I haven't been a program manager in a while. NEO is a platform for building smart economy solutions. There are a lot of these solutions in the marketplace. The things that set NEO apart is the single block finality for its consensus and a familiar developer experience that allows you to use the languages that you use, the tools that you already use, and to be able to build these solutions today. You can download the debugger, the visual tracker, extensions for Visual Studio Code, and the documentation is up on this link, bit.ly/NEO Toolkit. By the way, that is case sensitive. I discovered bit.ly is case sensitive, so capital N, capital T. It also has a link to the quick start where you can walk through the entire scenario for Hello World, and it has links to both the escrow scenario that we saw, the domains example we saw, and a cryptocurrency contract called CNEO that you can also experiment with. I will be here all day. I will be here at lunch. I unfortunately cannot make it to the Birds of a Feather meeting tomorrow, so if you would like to see me and ask any additional questions, please come find me. I mentioned at the top my Twitter handle is devhawk, DEVHAWK. Please reach out and contact me. We're really excited for customers like yourselves to experiment with this technology. If John was here, he'd make a comment about the fact that when it comes to blockchain, we're in the movie theater, we're still watching the trailers. So this is a great time to jump in and start experimenting with this technology while it's early, and get a chance to really help influence us in how we build these tools to make even better solutions for you. Thank you very much.